So today we're going to talk a little bit about modeling with quadratic functions. We'll start today given quadratic functions or equations and learning how to interpret different parts of them based on what we learned yesterday. And tomorrow we'll get a little bit more intense and we'll have to write the equations given other information. So let's just start with today when we're given information that we need to interpret. So here we go, exercise 1. An object is fired upwards with an initial velocity of 112 feet per second. Its height in feet above the ground is a function of time. In seconds, since it was fired, is given by the equation h of t equals negative 16t squared plus 112t. So part A asks, at what height was the object fired? Well, when it was fired is when it started. So we're looking for a starting point or an initial condition, which we've been seeing a lot is also our y-intercept. And in a quadratic function, the c term is our y-intercept. Well, here I have negative 16t squared plus 112t. I have no c term, so it's as if it's a plus 0. So this object was fired at 0 feet. It's just a y-intercept. If you know those properties of a parabola, some of the math can be quite easy. Part B, sketch a general curve of this equation below. So they mean it when they say general. So you need to know that we're starting at 0. It's a negative a value, so it's going to be a downward facing parabola, so it will reach a maximum and come back down and hit the ground. That's all we know now. We're going to finish labeling through the rest of the exercise. Part C, algebraically find the time that the rocket reaches its greatest height and the maximum height. Label these on the graph that you drew. So maximum height and time there, that's using our axis of symmetry and our turning point. So we'll say x equals negative b over 2a and substitute in. So I'll have negative 112 over 2 times negative 16, and that reduces to 3.5. So the axis of symmetry of this graph is x equals 3.5, which is also the x value of my maximum or my turning point. To find the height there, you have to substitute that in for y, or for x to find y. So y equals negative 16 times 3.5 squared plus 112 times 3.5. Use your calculator, and you'll get 196 feet. And the 3.5, by the way, is seconds. Units are important. So, 3.5 seconds into the flight, this rocket, or object, reaches a maximum height of 196 feet. That's how you interpret your turning point or vertex point. Part D, algebraically determine the time when the rocket reaches the ground. Label this on your graph in B. So the time, the x value is time, when the rocket reaches the ground. Well, that's a y equals 0. There's no height when you're on the ground. So we'll take our formula, or our equation, y equals negative 16, I'm going to call it t squared, plus 112t, but y is 0, so 0 equals negative 16t squared plus 112t. This is a nice review of solving quadratics by factoring. So we're going to factor out a common negative 16t and be left with t minus 7. We set both factors equal to 0 and solve. Well, negative 16t equals 0, divide by negative 16, we get a time of 0. But that's our starting point. We want our ending point. That's our other factor. So we set t minus 7 equal to 0 and get t equals 7. So 7 seconds into the flight, that object hit the ground. You could check that on your calculator. We'll practice the calculator next. So in exercise 2, we have a skateboard half-pipe ramp with a shape in the form of a parabola whose equation is y equals 0.06x squared minus 1.2x plus 7, where x represents the horizontal distance across the 20-foot wide half-pipe and y represents the ramp's height above the ground in feet. With the help of your calculator, sketch a graph of the half-pipe below, label its height at its endpoints and its minimum point. Okay, so we're going to use our calculator for much of this, but there's stuff we can do first. First of all, we have a y-intercept of 7, so you can label that on your graph. We know that this is a 20-foot wide half pipe, so we go from 0 to 20 on your x-axis. And at this point, we'll go to our graphing calculator. This is an upward opening parabola because it's a positive a value. It'll be quite wide because of that 0.06 and because it's a half pipe in a skateboard park. They're not very steep, not all of them anyway. So let's go to our calculator. So on our calculator, we can either add a graphs page to a new document or go straight to our scratch pad and get a graph scratch pad. And our function is 0.06 x squared minus 1.2x plus 7. Okay, so I'm seeing part of my half pipe, but again, they'll never give you a problem that's beautiful on your calculator, so you need to adjust. Now they tell me the width of the half pipe is 20, so I'm going to change this positive x value to maybe 25, so I see that endpoint. And now I have a better picture. Now we're asked for both that endpoint value and the minimum value. So let's find that second endpoint. We know that this one's 7. Let's go to a table and see what the value of y is when x is 20, because that's the other end. And there it is. It's 7. So when x is 20, y is 7. So we'll go back to our paper and label this other endpoint 27. And our first endpoint is there, the y-intercept, 0, 7. Now my calculator will give me lots of good information, including the minimum value. So I want my table to go away because it's a little messy. I move my label out of the way. And I want to analyze this graph's minimum. So I'm going to choose Menu, Analyze Graph, Minimum. Now remember, we always need to tell it where to do the math. So to the left of my minimum point is my lower bound. And then drag that line to the right of your minimum point, and as soon as you cross it, it's labeled for you. Click, and there it is. My minimum point is 10, 1. Label it on your graph, on your paper. 10, 1. There's the minimum point of my half pipe. And just draw a nice little sketch of it. Good enough. We've got good points drawn. So what I'd like you to do for homework is exercise number 3. The Crazy Caramel Corn Company. Okay, now, again, this is absolutely 110% a calculator problem. I'm not going to do much of this math by hand. So you're going to use your Inspire. Okay, you have an Inspire. Learn how to use it. Now, here it says algebraically determine the temperature at which the highest percentage of kernels pop. This says a negative a value. It's downward facing, so we're looking for a maximum. Now it says algebraically, so they do want you to use your axis of symmetry formula and then plug that x value in to find your y. You have a calculator for that part, and you have a calculator for this part too, but you need to show that substitution. Use your calculator to sketch a curve for p's greater than 0. Label. You'll probably have to adjust your window. Using your 0 command, that comes from analyze your graph, and then answer questions about it. You can do this. You need to use your calculator, look at tables, and write some good stuff down. And we'll talk more about that tomorrow. Have a good night.